Nearly 200 earthquakes were recorded in Yellowstone National Park in the past 2 weeks.
It is just a hint of what's brewing right here in the U.S. Scientists have long known that Yellowstone National Park sits atop a huge supervolcano.
Just recently, scientists at Yellowstone have discovered a dome-shaped uplift in the caldera system, which they believe is caused by the consistent flow of magma into the volcano. Today, we take a look at this Yellowstone system alert and the dome uplift underneath Yellowstone. Recent data shows that the number of geysers around Yellowstone is starting to grow, and live footage shows that they are more active than usual. In the last few weeks, the area has still been hit by a lot of earthquakes, and people who live there say that the shaking seems to be getting worse. There has been a lot of activity around Yellowstone Lake, where dozens of earthquakes have happened but haven't been reported. Even though Yellowstone has beautiful scenery and friendly animals, it can be frustrating for people who want to see its famous volcanic features. Geysers, hot springs, and mud pots are easy to find and can be very interesting on their own. But what about the big picture? What about the huge caldera, the huge lava flows, and the two huge domes that are growing back? Those recognizable parts can be hard to find if you don't know where to look. One reason is that they are almost too big to see. A short lesson in geological history will help us know where to look. Nature abhors a vacuum is a common saying, and it's true in Yellowstone and other calderas. Yellowstone caldera was made 631,000 years ago when a huge amount of rhyolite magma, about 1,000 cubic kilometers or 240 cubic miles, erupted explosively from a reservoir 5-10 kilometers below the surface. When such a large amount of water was taken out quickly, the roof of the reservoir caved in. After that, landslides into the chasm formed the shape of the caldera we see today, which is 50 kilometers by 70 kilometers. It's hard for the human eye and mind to grasp how far away these things are. But the magmatic system of Yellowstone wasn't done. Soon after the caldera broke apart, magma began to fill the partially empty reservoir. At two places where the eruption that made the caldera started, where the pressure was building up, the caldera floor rose by hundreds of meters. The resulting bulge in the east of the caldera became the Sour Creek Resurgent Dome, and its twin in the west became the Mallard Lake Resurgent Dome. Both features are shaped like an ellipse and are more than 10 kilometers x 20 kilometers across, with sides that gently slope. Resurgent domes are different from lava domes because lava domes are mostly made by lava flowing out onto the surface, while resurgent domes are mostly made by magma building up underground and pushing the surface up and out. The Sour Creek Dome grew taller than the nearby caldera rim before that area stopped rising. Its surface, like that of the Mallard Lake Dome, is cut by many faults that formed when the Earth was pushed up very hard. Early post-caldera resurgence probably happened at the site of the Mallard Lake Dome, too, but the evidence is buried under more recent deposits. But unlike the Sour Creek Dome, the Mallard Lake Dome went up again about 170,000 years ago. Near the beginning of the episode, the Mallard Lake rhyolite flow came out of vents on top of the dome. It covered most of the dome's surface and made it bigger. So Yellowstone's resurgent domes are not identical twins, but they are related. One was made only by structural uplift, while the other was made by both uplift and lava flow. In a series of eruptions from 170,000 to 70,000 years ago, more than a dozen huge rhyolite flows came out of the western part of the caldera after the dome started to rise again. These flows covered almost the whole floor of the caldera, and in many places they filled it up to the top. The high-standing upper sides of the Mallard Lake and Sour Creek Resurgent Domes are two exceptions. So there are two things that make it hard to see the caldera and its rising domes. They are so big that they are hard to find among Yellowstone's many smaller attractions, and some or most of them are buried by lava flows that are about the same size. On a clear day, you can see across the whole caldera from places like Mount Washburn or Lake Butte, which are on its rim. Don't be sad that there isn't a deep, steaming cauldron here. Remember that most of that space has been filled by lava flows. With the help of signs or a geologic map, you might be able to find the Elephant Back Flow, which is one of these lava flows near Lahardy's Rapids. You can see another one along Firehole Canyon Drive, where the Firehole River's power to erode has shown a cross-section of the flow's interior. And if you're looking for the resurgent domes, you can see the profile of the Mallard Lake Dome by looking west from the Delassie Creek Trailhead on the Grand Loop Road, about halfway between West Thumb and Old Faithful. At several points along the road between Canyon Village and Lake Village, you can see the Sour Creek Dome. Look east across the Yellowstone River to see a gently sloping shape on the horizon that looks like the shape of Hawaii's shield volcanoes. The Yellowstone supervolcano is big enough to cover Wyoming, Montana, and Idaho. Its name comes from the fact that it can cause destruction on a global scale. The USGS, United States Geological Survey, keeps an eye on it to see if there are any signs that a super eruption is coming, which hasn't happened in more than 640,000 years. Robert "Bob" Smith from the University of Utah noticed a change in the water level at Yellowstone Lake. This gave him a great idea about how the volcano's system works. His discovery was revealed by geologist Dr. Robert Christensen during the Inside USGS documentary on YouTube. He said, "One of the most interesting additional pieces of data came along after the early fieldwork and the completion of the initial geologic studies." Bob Smith at the University of Utah was interested in seeing if we could look for signs of contemporary deformation in the Yellowstone caldera. He had recognized some of these indications, particularly in changes in lake levels of different parts of Yellowstone Lake. And because it's so large, he felt there were indications that the lake basin itself was being tilted. Because of this, the lake level was rising at one end of the lake and falling at the other end. Dr. Christensen explained how his colleague discovered that the caldera was lifting below Yellowstone Lake. He added, he was interested in seeing whether we could actually measure this by some direct means. So one of the things I did at that time was to get funding together, to get the USGS Topographic Division involved in reveling. We felt that, with as much deformation as there appeared to be, that there should be measurable changes in elevations in the park. We finally got the funding together and got that survey done, and the data was provided to Bob Smith and his group, and they, in turn, integrated it into a series of elevation changes throughout the caldera. They demonstrated that the caldera over a 50-year period of time had come up about 2/3 of a meter and correspondingly less elsewhere. Later studies would go on to show that this was normal behavior for Yellowstone, as scientists observed periods of uplift, followed by lowering. Dr. Christensen added in 2014, "So it was a dome-shaped uplift that had taken place and a rather spectacular amount of uplift, indicating the magnetic system was active. Either the magma was intruding the crust or it was heating the hydrothermal system, causing it to expand and elevate the crust. Something was going on." There have been additional surveys that showed that after a period of continued uplift for a decade or so, there was then a period of stability for about a year, followed by subsidence. So we now know that the Yellowstone caldera is not simply going up, but up and down in a sort of breathing motion at times. Its overall deformation does seem to be an inflationary one, but it's not a steady sort of thing, and there are periods of deflation. A recent study also said that the hotspot might be waning at the moment. The results came from looking at volcanic deposits that were spread out over tens of thousands of miles in the area. Thomas Knott, a volcanologist at the University of Leicester, said in June, "We found that deposits that were thought to be from multiple smaller eruptions were actually huge sheets of lava from two previously unknown supereruptions that happened about 9 and 8.7 million years ago. During the Miocene, there were 2 supereruptions. This makes a total of 6 supereruptions in the area during this time, which suggests that they happened on average once every 500,000 years. The Yellowstone hotspot, on the other hand, has only had 2 supereruptions in the last 3 million years. Scientists think this could mean that these kinds of things are happening much less often. Still, the recent underground activity makes people wonder how big an eruption might be. In the last 10 years, the volcano has grown at the fastest rate ever seen. There are also between 1,000 and 3,000 earthquakes a year on average in Yellowstone. Most have a magnitude of 3 or less, which makes them almost impossible to notice. Still, these earthquakes show scientists how quickly the magma chamber under the park is filling up. If the shaking and rattling in the park gets worse, it could be because magma was recently added to the reservoir. Each of the previous eruptions sent out huge amounts of volcanic ash, gas, magma, and other volcanic debris that covered most of the continental U.S. Some of the material has even been found in Louisiana. After each of these eruptions, the Yellowstone supervolcano collapsed on itself, sucking in trees, mountains, and everything else in the area. A caldera is the name for the crater that this makes. The Yellowstone caldera is another name for the Yellowstone supervolcano. Yellowstone would face a huge natural risk if a volcano erupted and made a caldera. Scientists say that the last Yellowstone eruption was 1,000 times bigger than the famous 1980 Mount St. Helens eruption, which killed 56 people and thousands of animals and burned hundreds of square kilometers of land in Washington and Oregon. The Yellowstone supervolcano's last explosion sent a deadly cloud of hot ash, molten rock, and deadly gases thousands of meters into the air. A third of the continent was probably completely in the dark. Pyroclastic flows, which are fast-moving currents of hot, dry rock pieces and gases, move through the area at frightening speeds, burying or breaking everything in their way. The once beautiful landscape was burned for kilometers by magma that came out of the ground. The Yellowstone caldera, which is 50 kilometers, 30 miles wide, and 70 kilometers, 45 miles long, shows signs of the last eruption. In a place called the Lava Creek Tuff, you can still see the thick volcanic debris that was left behind after the eruption. Unlikely to erupt. The United States Geological Survey, USGS, says it is unlikely that there will be another big eruption like the last one. In fact, the Yellowstone Volcano Observatory says that hydrothermal explosions, eruptions of steam and hot water instead of molten rock, and lava flows are the most likely things that could happen in the future. Even though lava flows are a type of magmatic eruption, they are not as bad as the explosions that make calderas. Lava flows don't destroy everything right away. Instead, they come out of the ground slowly over days, months, or even years. They also don't happen very often. About 70,000 years ago, Yellowstone had its last lava flow. Hikers can still see evidence of these eruptions in the form of different rock layers along the trails in the park. Near the cliffs around the Upper Geyser Basin, near Old Faithful, there are signs of more recent lava flows. Old Faithful is a geyser and one of the most visited places in the park. Today, Yellowstone is sleeping, and scientists are watching its every sneeze and cough to try to figure out what it will do next. Yellowstone has been sleeping for thousands of years, but that doesn't mean it won't wake up one day. The force that has been building up under the park has been held back. The question then remains, when and with what force? That pretty much wraps this video up, guys. Thanks for watching. So, what are your thoughts about a possible eruption of the Yellowstone supervolcano? Share with us in the comments below. Make sure you subscribe to this channel with a bell notification if you enjoy watching our content. We upload some awesome stuff here, which you will most certainly enjoy. Hit a like on this video and leave a comment below. See you guys in the next one.